Hello everyone, my name is Ryusei Nagasawa from Matsui Asia. Thank you very much for joining today's guest seminar. I will be the speaker for this session. Please enjoy the presentation. I am working in Thailand at Matsui Asia, which is the main base of Matsui MFG in Asia. I do sales and customer support for molding factories. Today, I want to share some ideas about gas problems in injection molding. After this seminar, I believe you will find a new way to improve your gas troubles. Let's work together to reduce defects and make your company more profitable. Now, let's start the seminar. Our company is Matsui MFZ, founded in 1912 in Japan. We make and sell molding support systems. Our market share is about 40% in Japan and around 50% in Asia. Matsui has 87 offices in 26 countries around the world. Our goal is to supply plastic materials stably and safely. To do that, we make many types of equipment. For example, dryers, blenders, and combining systems. We also supply mold temperature controls, mold insert parts, and water quality improvement system to keep molding conditions stable. Our company vision is called Factor 4. It means cut cost by half and double quality and profit. So finally, we make 4 times more value. To reach this vision, Factor 4, Matsui promotes 12 improvement themes. Today's seminar will focus on theme number 8. Reducing gas defects. Okay, now let's move to the main topic, how to reduce gas problem in injection molding. Do you have molding defects such as wrapping, short shots, burn marks, fresh or white weld lines? These defects often happen because of gas generated from the resin. That means gas venting is very important. Injection mold is always a kind of battling against gas. Now, I will explain how gas venting works. Let's start with a basic mechanism. The video shows the purging process. In the heating cylinder, the resin stays and decomposes by heat releasing gas outside. At the nozzle tip, decomposed gas gather and flow into the mold. First, the red gas enters, followed by the yellow resin. A vent is set at the end of filling to release the gas. When gas enters the product area, small amount of soot stick to the air vent. If molding continues, the soot blocks the vent. When a short shot happens, maybe you change the molding conditions to fix it. But that is only a temporary solution. Even if you increase pressure, the problem will come back because the vent is still blocked. When the vent is clogged, you have to stop molding and clean the mold. If you don't clean it and just raise the lead injection pressure, burn marks will appear. Again, you will need a maintenance. So let me introduce our product, GasTOS. GasTOS is special ejector pin with a hollow center and a slit at the tip for venting gas. It has a through hole in the middle to let gas escape. At the tip, the slit width can be selected according to the leading from 5 to 50 microns. By installing GasTOS under the sprue and at the end of the runner, you can stop gas from entering the product area. This is the key to success. It's very important. Let's compare. One the left with GasTOS, one the right without GasTOS. With GasTOS, gas is removed before reaching the product area. Now let's see it again in a slow motion. The vent area is enlarged. Left side with GasTOS, right side without. Less gas enters the product area, so less soot correct in the vent, and maintenance become less frequent. By improving the venting effect, you can mode under lower pressure as well. Here is another comparison. The left image shows low pressure moding using many GasTOS units. Gas escapes smoothly from the final filling area. Left side is with GasTOS, many of GasTOS, yes. And right is two of GasTOS. Continuous moding become possible, making lazy flow stable and preventing vent clogging. Here you can see the enlarged image before the gas enters the product area. The upper one has GasTOS, the lower one does not. As you can see, we can run the process continuously and stable with GasTOS. This video comparing GasTOS and plastic bottle section using a plastic bottle as a mold, compare the section effect depending on the number of the GasTOS used. We prepare 4 GasTOS, pin size 5/8, slit 0.2 millimeters. Open and close the valve by the number of GasTOS. Check the compression condition of the plastic bottles. This is the GasTOS. Can you see the slit at the tip? We will now connect 4 of these GasTOS pins and start the section test. This video shows the section comparison between 1 and 4 GasTOS. As you can see, 4 GasTOS can be sucked much faster. The more GasTOS you use, the larger the suction area and the stronger the suction power. Next, I will introduce the item that can be used for suction. The upper part of the image shows the end of cavity is sucked directly. The lower part of the image shows the cavity is sucked from the back side of the ejector plate. It is effective for hot runner mode to suck from directly below the gate. If the shade of the product is not flat, our Super GasTOS is the ideal choice for additional machine of the tip surface. When the product size larger, increasing the number of GasTOS will be more effective.
The GasTOS shown in this photo is available in ejector pin type and core pin type. To vent the gas, simply replace the normal ejector pin with one of the same size. The feature is excellent exhaust efficiency with a tapered shape from the tip to the back end. It prevents vent clogging of a cavity by exhausting gas and air from runner end part. This gas venting parts allows 3D shaping of the tip. The pitch between the grooves is processed to 0.1 mm and the exhausting capacity is excellent. The block type can be cut into a secondary shape by wire cutting. 3D shaping is possible with EDM. It has two layers, and the vent width of the first layer can be selected from two types, 0.02 and 0.03. The second layer has a 0.35 by 0.35 back relief hole to reduce the gas clogging. The degassing pin can be taken in and out while the mold is set on the molding machine. After cleaning the inside of the degassing pin and inserting it into the mold, you can start your production immediately. You can suck some of the gas from the edge of cavity. Even products with the deep ribs are suctioned to prevent gas burns. The suction of air and gas from the runner end before passing through a gate prevents vent clogging of a cavity.
Increasing a gas spending helps decrease molding machine size and reduce the mold man hour and man hours. The three photos above show example of how increasing the number of gas stops by 2 result in lower mold clamping pressure and shortened cycle time. If the optimal gas release position and number of gas stops are clearly indicated prior to the mold fabrication, it will lead to shorter mold construction period, downsizing of the molding machine, and cost reduction. we were able to show in the flow analysis about two patterns of degassing. The flow analysis was performed with MoldX 3D software. Normal analysis shows that the filling can be done in 2.61 seconds. It takes 19.3 seconds to fill, but cannot be filled. When installing 4 gas hoses under the sprue and runner end, the analysis shows that it takes 3.16 seconds to fill. Now, when installing 5 gas hoses, the analysis shows that it takes 2.65 seconds to fill. From what we have seen so far, you can understand how important it is to remove gas from the mold. Of course, gas hose alone is effective, but we also have another solution that gives even better result when we use together. That is the gas suction unit shows on slide 12. The gas suction unit is a device that removes gas trapped inside the mold. Its main features are reducing equipment failure caused by gas and lowering maintenance frequency. It can also suck gas without cooling the mold. The design is compact and maintenance is very easy. There are 2 models, MAG 01P for short weight under 500 gram and MAG 02P for larger short weights. The required utility are only compressed air, a molding machine signal, and a 100-volt power supply. As I explained before, gas can be removed by using the suction unit together with gas hose. However, even without gas hose, suction can still be done. By machining the mold as shown in the photo, gas can be sucked from the air vent of the ejector pin or the air vent inside the mold insert. This video shows a demo trial using both the gas suction unit and gas hose. Normal ejector pin without gas bending are used under the sprue and runner area. We use the side type super gas hose for suction. Flow analysis compared the pressure at 2 points A and B. There was a big difference between suction on and off. This area is the final filling point. Now please watch the test. In this trial, suction was turned off first and then on, and then off again. The gas suction is using MAG 02P. It is now in off mode. When suction is off, gas stay in the mold and cause short shots. Next, suction was turned on. When suction is on, gas is removed from the mold and short disappear. Then it's amazing. Then we turn suction off again. When suction is off, short appeared again because gas could not escape from the mold. Next, we made another test to create gas burn on purpose by using strict molding condition. First, we ran molding without section off, with section off. Then we increased the injection speed to make gas burn appear. Next, we turn section on. When section is on, short disappeared, but small gas burns remain. We continued molding without cleaning the mold. After several shots, the gas burn marks become lighter. After about 10 shots, the gas burn mark disappeared completely. Finally, we are going to turn section off again. Let's see how changes. When section was off, both gas burns and short appeared again. From these tests, we confirmed that section has a clear positive effect on product quality. As you saw in the demo trial, using the gas section unit can be reduced gas burn, short, and maintenance frequency. Today, we talk about the importance of gas venting in injection molding. Thank you very much for joining this seminar. We also have a demo unit of the gas section device, MAG. If you are interested, please scan the QR code on the right and contact me directly. Thank you again for taking time to join this webinar. Bye-bye.